Hello? Hello? There we go. You can hear it now. Mm-hmm. By the way, I can't return the microphone. It's been over 30 days. Good evening to everyone. If you are interested, I do have some items over here. If you'd like to check them out, you're free to take any, or you can wait until after. I have no idea. Yeah. Mm. Stay home. Yeah. Let me, I'll open open that. I didn't realize it. Oh, there we go.
Yeah, somebody opened.
Yeah, okay.
Thank you so much.
Mm-hmm. There you go.
Thank you.
So let me do it like that. There we go. Hello. Hello. So if you see any problems with YouTube, kind of let me know. And if you see any problems with YouTube, if you identify that there are any problems with YouTube, point toward that. Hmm?
How long are you usually in space?
I'm never in space. I haven't been, but it depends on what the mission is. Some astronauts may go for only a couple days, but some may go for months and months. It depends on. We haven't had any astronauts go for years. Normally, the maximum amount of time would be months, but that will change in the future.
And I heard, are there life on a different planet?
We're not sure, but considering how big space is, it would be very, very difficult that there isn't life somewhere out there. So NASA hasn't found it yet. But I think that one day we're going to find something. What do you think? Yeah.
That would be pretty interesting.
That would be pretty big, huh? Good evening, everyone. How are you? Good, good. Welcome. My name is Mark Gillette, and I want to welcome you to my presentation, How NASA Explores the Solar System and Beyond. If you're wondering what this is right here, I'm doing a YouTube Live in addition to having all of you here in the room. For those who didn't get the opportunity to come that would like, hopefully they have an opportunity to participate via my YouTube Live channel. So again, my name is Mark Gillette, and I am an ambassador for NASA. My full-time job is that I am a sociology professor at Valencia College over in Orlando and Kissimmee. I've been teaching there for about 30 years. And so you might be thinking to yourself, okay, what does sociology have to do with space and NASA? Well, not necessarily a whole lot, but space and NASA has always been an interest of mine. So over the last 7 years, I've been fortunate enough to get the opportunity to go out into the public and to share some of the fascinating missions and projects that NASA has been working on. So, this is the agenda that I have for us tonight. These are the missions that I'd like to talk about. We'll talk about the International Space Station, or the ISS. We'll talk about the Artemis program, Perseverance rover, and the Ingenuity helicopter, the James Webb Space Telescope, fascinating mission, the double asteroid redirection test that was done, the OSIRIS-REx and Bennu mission, Psyche, the Europa Clipper. And I want to show you a really neat, cool program that you can go to on NASA's website called NASA Eyes. Tell you how you can get interested in get involved with doing some NASA science, and then we'll wrap it up with Q&A. Anytime during the presentation, if you'd like to jump in, feel free to do so at any time. If you have any questions, I can't guarantee that I will have an answer to your question. And if I don't have the answer, I won't make one up. I'm simply going to say, I'm sorry, I don't know that. But I will try to address all of your questions as we go through. All right, sound like a plan? So again, welcome. Glad that you could be here to spend part of your evening with me. And so let's take a look at how NASA explores our solar system and beyond. And we'll start with the International Space Station. It is, in fact, international, and it's not just the US. We have many partners in this project that was first inhabited back in the year 2000. So it's been about 25 years that we've had astronauts continuously living on this football-sized satellite, basically, that's roughly 250 miles above us. That ISS is traveling at roughly 17,000 miles per hour above us. So it takes roughly about 90 minutes for them to orbit the Earth one time. It is the size roughly of a football stadium, powered by solar panels, has generally between 6 and 10 astronauts at any one given time. NASA is really into symbolism. And so if you know anything about NASA, they come out with a patch for everything. And so this is the patch for expedition number 72. Astronauts generally spend about 6 months on the International Space Station. And so when the next crew comes on, they come out with another patch, and then we move to the next number. So this is the current patch. If you want to see the ISS with your own eyes, all you need to do is go on the internet and Google International Space Station, spot the station.nasa.gov, and you can sign up for alerts from NASA, so that when the ISS is visible over the area that you happen to be in, you will get an email, and the email will tell you exactly what time to look, where to look, and how long it will be visible to you. Now, when you look up in the sky, the ISS will not look like this. It's basically going to look like a little dot going across, a little white dot going across the sky. Okay, so don't get too excited. But using your imagination just a little bit, you can put together that that little dot has 7 or 8 human beings on it, traveling 17,000 miles per hour above us. That's pretty cool. That's pretty cool. So check it out. So it's been 25 years worth of science. It is coming to the end of its life. And so NASA is trying to determine how best to deal with wrapping science up on the International Space Station. One option is basically letting it come back into the atmosphere and burning up. Another option would be trying to deorbit it and trying to save certain components of it. And that's something that NASA is kind of debating as to what's the best scenario for the ending of the ISS. All right. The next thing I'd like to talk to you about is the Artemis program. So again, if you know something about NASA, and I'm sure that you do because you're here, you remember the Apollo program back in the 1960s and 1970s, and that's our first venture to the moon. Well, when the last mission ended in 1972, because apparently Americans ran out of interest in the space program and Congress cut the funding, it's been a long time since we've actually been to the moon. Between 1981 and 2011, we had the space shuttle program. And the space shuttle program was in low Earth orbit. So the space shuttle would go up about 250, 350 miles above the Earth. It would stay for a week or 2 weeks. They'd do science, and then they would eventually come back, landing like a plane, all right? Launching like a rocket, landing like a plane. But then NASA, back in the 2000s, decided that they were going to end the space shuttle program and go back to going to the moon and beyond. And so NASA has created what's called the Space Launch System. And on the right-hand side of the screen here, you see the Space Launch System rocket. Okay, it probably looks a little familiar to the Apollo 5 Saturn V rocket. Okay, but there are some differences in that the Saturn V rocket did not have solid rocket boosters. Okay, it had 5 engines, hence the name Saturn V rocket. This rocket has 4 engines, and the engines actually come from the Space Shuttle program, RS-25 engines that have been supercharged and put on this SLS rocket. All right. The big orange tank that you're looking at here, this is for the liquid oxygen and liquid hydrogen, okay? Where this is built by Boeing. At the very top, that you can't see it behind the fairings here, you have the Orion space capsule. This is where the astronauts go, right up there, okay? Going back to the solid rocket boosters, they may look familiar because during the space shuttle program, the space shuttle itself had 3 main engines, the engines that were incorporated into this, but they had those white solid rocket boosters. And so they were incorporated into the Space Launch System rocket. And it's interesting to know that these 2 white solid rocket, and that's the title is for a reason, because it's solid propellant, unlike in the orange tank where it's liquid. These are solid propellants. And these 2 white boosters do about 75% of the lifting or the work to get this entire rocket into space. So the other 25% is done by the 4 engines here that you can't see. All right. Going back to the Orion space capsule, it can accommodate up to 4 astronauts. All right. This is the crew capsule that will be used to take the Artemis 4, the Artemis 2 astronauts to the moon. This is currently scheduled to take place no earlier than April of next year, April of 2026. My gut feeling is that that date will probably slip, as it has slipped quite a bit already. But there will be 4 astronauts that will be inside of the Orion space capsule, which will go on top here. And they're going to go around the moon, come back. They'll be gone for a few days. Those 4 astronauts have already been selected. All right, if you want to see who they are, you can go on NASA's website. But we have something different that we've never had before, and that is we have 1 woman and 1 person of color. In addition to that, this is an international project, much like the International Space Station. So we also have a Canadian that will be on board. Okay, so pretty exciting.
Who's the 4th person then?
So the 4th person is a gentleman who will be the commander of Artemis 2. We had Artemis 1. Artemis 1 launched from Kennedy Space Center on Tuesday, November the 16th. And the purpose of that mission was basically to test out all of the systems, because this was the very first time that this rocket had ever been launched, the first time that the Orion had been mated with the entire rocket, and most of the things went quite well, better than they expected, but there was one pretty big problem, and the problem was the heat shield, and you can't see the heat shield. This is the service module, has a lot of the computer wires and technology that's needed to drive the Orion capsule and the rest of the rocket. But when this returns, this is the only thing that returns to Earth right here. Right below here is a heat shield. And there were some problems with the heat shield as it returned to Earth. So they did a lot of work, a lot of research, a lot of testing. And what NASA concluded just 2 or 3 months ago was that they're going to approach returning to Earth with a different path. And that's going to reduce the amount of heat that builds up on that heat shield, and everything should be okay. How? So, okay, I'm not an engineer, but here's my understanding. Let's say my hand is the Orion spacecraft, and this is Earth. And so if I bring the Orion spacecraft down like this, it's going to generate a lot of heat because it's basically coming right down. What NASA is going to do is do one of these instead. And that should help to decrease the amount of heat.
Gravity do the rest.
And gravity will definitely do the rest. All right. So I just added this in here not long ago because it's interesting to know how fast these capsules are when they return to Earth from going into space, and it depends on where they have gone. So when they come back from the moon, all right, the heat shield will be dealing with temperatures in excess of about 3,000 degrees Fahrenheit. Okay, they're going to be coming in about 17,500 miles per hour. Talk about a roller coaster ride, huh? And they've gone about 250 miles above or beyond, like to the moon. Okay, that the criteria is about the same. But notice how it changes. I'm sorry, this is for low Earth orbit, this is for the moon. I want to mention here Mars. This is the same rocket that's going to be used to take NASA astronauts to Mars in the future. That's the plan now. Of course, the plans can always change, but the plan is to use the same rocket. It's going to take roughly about 9 months. It only takes a couple days to get from Earth to the moon. You stay a couple days, takes 2 or 3 days to get back. You're looking at 7, 8, 9 days. All right, sign me up or go. To go to Mars, you need certain things to align, like you need the Earth and Mars to be at a special place so that you don't spend 2 years to get there. You can do it in only 9 months. Okay? And so then you get there and you can't immediately turn around and come right back because the planets aren't in the right alignment. So you're going to have to wait some time, and then you've got a 9-month journey back. You're looking at probably about a 3-year journey to go to Mars and to get back. Okay? Don't sign me up. Okay?
Are they still looking to do on the moon, set up living quarters, so for lack of a better term, on the moon to assist with the Mars journey, so that they don't have as far to travel?
Yep. So if you couldn't hear the question was, does NASA still have plans to set up some type of a base on the moon as a jumping point to go to Mars? And the answer is yes. Those things are under construction. The point at which these the base is going to be set up is actually going to be at the south pole of the moon. And I put a little drama in there because that's a big difference between now and the Apollo days. In the Apollo days, most of the Apollo missions landed somewhere around the equator. Okay. Now we're going to the South Pole. Why? Because there's ice, water ice, and that water can, of course, be used for drinking purposes, but it can also be divided into its hydrogen and oxygen and used for rocket fuel. As I mentioned earlier, you have liquid hydrogen and liquid oxygen in there. So the fuel can be produced there at the moon, and then theoretically, the spacecraft could be launched from there to go off to Mars. And there isn't hardly any gravity on Mars compared to Earth, so there's a lot less use of fuel. So it's a lot more efficient to do it this way. So yes, those things are in the works. In fact, there's another thing that kind of fits into this, and that's what's called Gateway. Gateway is going to be a relatively small ISS that will be orbiting the moon. And that is under construction, and it's supposed to be there in place before Artemis 3. And Artemis 3 will be the mission where 2 astronauts will be going down to the surface of the moon. Now, currently that's scheduled for late 2027. I'm thinking probably not. It's probably going to slip, but that's the goal at this time. So Artemis 1, it's already taken place. Everything went pretty good, except for that heat shield problem that I told you about. NASA found a solution. Now we're working on Artemis 2, coming up no earlier than April of next year. 4 astronauts launch from Kennedy Space Center. They go around the moon. Why are they doing that and not landing? Now we have humans on board the Orion space capsule, testing out things that it couldn't do on its own in Artemis 1. Bring them back, prepare for Artemis 3, going back to the moon. Okay?
Any of those boosters reusable?
No. They were for the space shuttle program, but they are not for this program. Okay? And there is a big there's 4 sections to this, 4 segments. The space shuttle program had 3. Okay, so they needed to add more propellant to get this beast off of the ground. So no, they will not be reused for this particular program. Okay.
Why do they select the name Artemis? Obviously Greek.
Yep. So Artemis is the twin sister of Apollo. And NASA loves to use the Greek gods and all that stuff for their program. So it seemed to be a nice fit. Okay. So, all right. So that's the Artemis program. Pretty exciting. Yes. Anybody want to go? Who wants to go to the moon?
No,
No.
I like terraforming.
Few of you. Who wants to go to Mars? Much riskier. Much riskier. Speaking of Mars, lots of things going on at Mars. Why? Why are we so fascinated? Why are we so fixated on the planet Mars? Huh? Why not? Okay, I love that answer. That's why I get excited about any of this stuff. My question is always, why not? To me, it's intellectual curiosity. It doesn't matter. Let's just go check it out and see what's going on. The universe is really, 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 really big. And we're living on one little tiny planet. And we're very boxed in. And so there's lots of opportunities. So let's go explore. So, of course, NASA is going to want more specific reasons on why we go there. And so what are some of the more specific reasons that we're fascinated with Mars? What's that? Okay, yeah, there's always that angle. What else?
Minerals.
Okay,
Being
there may
able
be,
to mine.
there may be resources that we could use one day. Same thing with the moon. What else? What's that? Communication.
We are overpopulated.
We may need to find another place to live. If you keep up with the news at all, we've got some challenges here on planet Earth. And so we may need to find an escape place to live in the future. It's lost its atmosphere. Okay? It's believed that many, many years ago, Mars had an atmosphere much like ours, and it had rivers and lakes and oceans, and something happened. Something clearly happened that changed all that. We don't want that happening here. So we go and try to do some research to figure out what happened there so we can maybe prevent it here. Of course,
Looks like the Mojave to me.
yeah, yeah. And perhaps one of the other biggest questions is there life out somewhere beyond planet Earth? I often get the question. I get this question. So the NASA answer is we don't know. We don't know. Okay? When you think about the size of the universe, when you understand how planets form, and you understand that the Earth in our solar system is not the only game in town. In other words, there are lots and lots of other solar systems out there. It may not take the miracle that we think that it may take to get life to form and to develop. Okay, I'm looking at this from a very scientific perspective. All right. So personally, I would be shocked if there wasn't something else out in the universe. Okay. The problem is everything is so far away that it's hard to get there to do the research. All right. So there are organizations like the SETI Institute, if you've ever heard of that, the organization that sends out radio waves into the universe to see if there may be something or something out there that may want to communicate with us. All right, what's going on here? Here we go.
Now, see, that's
Yes, this is Mars. So I can just imagine getting on the internet and seeing the headlines, life discovered blank, Mars, wherever. Is that not the biggest news humans have ever faced? I can't think of a bigger news story to find out that in fact there is something else out there. And that's, I think, going to change everything. So it's a very exciting thing to think about. Thank you. Very exciting thing to think about, and time, I guess, will tell. I don't know if you're familiar with a gentleman who passed away a few years ago, brilliant scientist, Stephen Hawking. When he was asked the question, is there life out there? He said, yes, absolutely, no question. But then he went on to say, we better hope that they don't come visit us. Because if they come to visit us, that means that their technology is much superior to our own. Now, hopefully they come in peace. Who knows? But, I'll leave it to him. Are you all familiar with the Ingenuity helicopter that took a ride with the Mars Perseverance rover that's on Mars, that's been there now a few years? So you can go on NASA's website and see exactly where it is and what science it's conducting at the moment. But I'd like to talk about the little helicopter that went along for the ride. A helicopter had never been flown on any other body anywhere. And so the scientists at JPL in California said, hey, why don't we bring along a little helicopter and see what it does? All right. Again, as I said earlier, Mars doesn't have much of an atmosphere. And as a pilot, I understand that you need atmosphere for your plane to stay in the air. Something, how I like to describe it is, your wings kind of have to grab on to something. All right. Well, if there's nothing to grab onto, like Mars, is it going to work? Is it going to fly? So here is some video Let's see here.
You have to advance the slide.
Why is it not letting me out? There we go. So this is actual video. The camera was on the Perseverance rover that I showed you on the left-hand side. It's pointing to the little helicopter right there, spinning its little wheels. So this is actual footage. This is not, you know, AI. And there it goes. It flew up, only stays up a few seconds, and then it's going to come right back down. But the key is it worked. It flew. And they weren't sure that it would. And they designed it and they engineered it in a way that the blades were in a particular angle and they were spinning really fast, and there were 2 sets of them. And this little character here flew more than 70 times, and each time they brought it up higher and they flew it further. And it worked better than they ever thought that it would. What would we do with something like that? We're not interested in dementia at the moment. We'll worry about that in a few years. But what can we do with this thing? Well, when the rover is moving around, there may be a big hole that the people operating the rover may not see with the angles of the cameras that are on the rover.
How are you operating it from Earth
They're operating from Earth,
to the space station?
and they're using the rover here to send the messages too. So it's kind of going from what's called the Deep Space Network, which is how NASA communicates with all these things out there. They send the messages to the rover, and the rover sends them to the helicopter.
So I guess they're bouncing off the satellites.
Yes, yeah.
And it's all in real time. There's no delay.
There is a delay. There is a delay. So it's already, yes. So it's already kind of happened before, we see it.
Crashes with like astronaut, like a different rocket, like a rocket and rocket
Crashing together. Luckily, we haven't had that problem. But there's a lot of trash up in space that's accumulating, and it's becoming a bigger and bigger concern. So we talked about the International Space Station a little while ago. As more and more stuff is going around in space, there's a concern that something may hit the International Space Station. It's happened before. But if it happens at, all the things line up perfectly, and it's not going to end well. So, but no rockets crashing together.
But it's hard to land those things on Mars.
Very
Yeah,
difficult.
following.
Very difficult. And if you want to see some really cool video, go on YouTube later and look for the landing and descent of the Perseverance rover. And they've got some really awesome video landing this on, and it is very, very difficult and very, very challenging. You need extremely smart people to run all the math and make sure that they're bringing it at the right angle and the right speed. And if something goes wrong, lots of people's time and lots of money is completely gone. All right. Just about a month ago or so, there was a satellite that was landed on the moon by a private company, if you follow the news, and it didn't land upright. It landed at an angle. And so there's a lot of time and a lot of money. And, but
And you don't have anybody there to go.
you don't have anybody there that can go and lift it up and fix it. All right. These things are far away. So a lot of people would say there's too much risk in this stuff. There's too much risk. We put too much money into this. But I say completely the opposite. You have to take risk. Just like I tell my students in life, it's not just space. It's just life in general. You have to take calculated risk to move forward, to evolve, to expand. And so NASA does some of the biggest risk, but they come out with some of the most incredible information. And that gets me really excited.
So what is the rover and Ingenuity collecting?
So they're doing all kinds of research. There are all kinds of instruments here on the rover that will dig down into the soil. It's actually collected samples, and those samples are ready to be picked up and returned to Earth. We've never gotten samples back from Mars yet, but there are a number of instruments on board that can take some of that and shift through it and analyze it to see, are we seeing any signs of past life? We're probably not going to find any green aliens walking around Mars, as we've heard in our stories, but we're probably not going to see any, little lizards running around either, because without an atmosphere, it's a very, very hostile environment. But we might see that there was life a long time ago, so we might find some remnants of something that did live. And so by collecting that soil and doing the analysis, they're hoping to see, hey, are we coming across something?
Back when it had an atmosphere.
Yes, right.
How do they get that on and off the planet? Do they send it in a little capsule and it opens up and lets it out, or?
So
'Cause
let's
I can't see
see.
them dropping that from the
Yeah.
aircraft.
No, so this is all folded up and put on the top of a rocket, much like the SLS that we showed. I don't know which rocket was used. I think probably a SpaceX Falcon 9 or a United Launch Alliance rocket. So they put it up in there, all folded up, and it has a fairing around it to protect it as it goes up into the atmosphere. Once it gets out of the atmosphere, they take away the fairing, and then it starts its 6, 8, 9-month journey to Mars. And then once it gets to Mars, again, I would invite you to go on YouTube later, and you can actually see how they do some really cool things before they land. They kind of open it up, and there's a big balloon that comes out just as it gets ready to land. So you have to have some really smart people work on this stuff to get this all to work. And they do. I mean, NASA kind of pulls it off just like that, which is pretty cool. All right, so let's keep moving on. 6:03. Speaking of cool, so we have the Hubble Space Telescope. Everybody's heard of Hubble. Yeah, it was launched in 1995. So it's been up there for what, 30 years now? It's about the size of a small school bus. Whenever you see pictures coming from NASA, except for the last couple years, most of those pictures have come from the Hubble. But as anything goes, it ages, has problems, and so NASA decided that it needed kind of like a replacement. And so they started developing the James Webb Space Telescope even before Hubble was launched in the mid-90s. Took a long time to engineer and develop and build the James Webb Space Telescope. It was delayed by many, many years. It was quite a bit over budget, but they did finally get that thing launched on Christmas Day 2001. And to me, I can't believe it's already been 3 years. It just blows my mind. It seems like just 2 days ago. 2021, yes, I'm sorry. Yeah, I'm sorry, 2021. But 3 years is, it's like, oh my God, it seems like just a few days ago. I was watching the whole thing kind of unfold. But so the James Webb Space Telescope uses infrared photography, which is different than Hubble, which uses basically things like that's in our cameras for the most part, visual photography. And so we could not launch it and put it up in low Earth orbit like Hubble, which is like 350 miles above us. We had to send it far, far away. And the reason we had to send it far away is because the Earth emits heat. And heat and infrared technology don't work well together. So we had to get it away from the heat that the Earth radiates. And so they send it to a Lagrange point, which is a nice sweet point when it comes to gravity among the Earth, the Moon, and the Sun. So it took about 30 days after launch to get it from Earth to its new home, about 1 million miles away from Earth. Okay? It is about the size of a tennis court. And you can't put something that big on top of a rocket, like I was showing you earlier, all opened up. So they had to build it so that everything folds up and closes up. And then once they get into space, then they have to start opening it all up. So this is the process that it went through. Launched from Earth, this is it, all folded up. And then there were different stages at which different things were opened. There were over 200 points at which if something did not open perfectly, if some little bolt didn't snap into its right place, the whole telescope wouldn't work properly. It all worked perfectly, better than they even thought that it was going to work. All right. So after about 6 to 7 months of it being in its new home and doing testing, they were able to start taking the images. And this is the, if you remember the news on the right here, this is the very first image that was released by the James Webb Space Telescope. So this would have been, I think it was June or July. I think it was July of 2022. All right.
Markedly different from Hubble.
Very different. It's the same area of the sky that Hubble took. It was called the Deep Sky project. So what are you looking at here? Everything that has these, looks like a star here, these are all stars within our Milky Way galaxy. Okay? So those are all stars. Let's ignore those for a moment. Everything else that you're looking at here is a galaxy. So we live in the Milky Way galaxy. What is a galaxy? A galaxy is a collection of stars that have all come together due to gravity. With each star, scientists now know that there's at least one planet that orbits that star. We didn't even know this until the mid-1990s. Prior to the mid-1990s, we did not know that exoplanets, even existed. We only knew that there were 8 planets in the universe, okay? The 8 that we've been familiar with. We're not going to talk about Pluto, okay? But then scientists came up with ways using different techniques to discover that in fact, again, on average, each star has at least one or more planets. So you're looking at, in any one of these, millions and millions of stars that make up that galaxy. One star has one or more planets. Start to do the math. In this one picture here, there are more than 10,000 galaxies that are visible. This makes up, if you hold your hand up like this, you go outside tonight and you hold your hand up like this, this is the amount of the sky that's collecting right there. So if we take a picture there, what about here? What about here? What about here? Are they empty? No. It's crazy. It's crazy.
It's an excellent telescope.
Oh, yes. It's crazy.
The detail from Webb compared to Hubble is
yes.
because of the infrared.
Right. It's unbelievable. It's just, and when you start thinking about the possibilities, you know, we are in our own little worlds here living on planet Earth. And we go about our days and we get very sucked into our issues and problems. But think about what's going on out there. It blows my mind. The Space Telescope Science Institute in Maryland, that's the organization that runs the James Webb Space Telescope. Okay, NASA normally contracts with different schools, universities to run different things like Hubble. For example, the Perseverance rover I was showing you on Mars. Mars is run by JPL in California. So this is run by the Space Telescope Science Institute in Maryland. Okay, so very exciting. How many of you have heard about the DART mission? Anyone?
No.
All right, so this was
Big names.
a really cool, yeah, NASA loves acronyms, the Double Asteroid Redirection Test. So there are lots of things flying out there, stuff that we've put out there that are good things, that are satellites, things that aren't so good, satellites that are no longer usable, so they become trash. We've got the ISS, lots of things out there. We've also got non-human made things like asteroids. And as you know, many millions of years ago, there was an asteroid that hit the Earth and it wiped out the dinosaurs 65 million years ago. Okay, bad day. Okay, it's a bad day. And we don't want to relive that bad day.
I have a question about the James Webb. How fast is it traveling right now?
So it is not necessarily, so like the Webb is orbiting the Earth, so it's going 17,500 miles per hour. The James Webb is in its own sweet spot in the Lagrange point 2. Everything in the universe is moving. I don't know what the exact speed is, but it's not orbiting anything. But I don't know what the speed is in relationship to everything around it.
Is it actually orbiting the sun?
Yeah, no, it's not. Oh, thank you. It's not moving all around. It's in that sweet spot, but I don't. It's moving at some speed. I don't know what that speed is.
Is it going further away or?
No, it's staying put. Yeah, so it's moving, but I don't know what speed it's moving at. But it's moving in relationship to everything else that's moving, which is everything. So I can't answer your question. We don't want this to happen again and be a bad day. So NASA, a long time ago, decided, what can we do to prevent a bad day? Can we send some type of a spacecraft and hit it? And will it nudge it off course? Okay, will it work? That's what this mission was about. September 26, 2022. Okay, give me 1 second here. This will work. Okay. Okay, give me a slideshow from current slide.
Coming at you fast. Frontier Fiber 7 gig on Wi-Fi 7, plus Wi-Fi security, whole home Wi-Fi, and premium tech support. Get the premium internet package that keeps getting better. Frontier Fiber 7 gig. You're good to go.
All right. Again, this is real video taken from the DART spacecraft. How do you like it? Pretty cool video, isn't it? All right, why am I not? When you put this in presenter mode, it really likes to do its own thing. Did I have it? And I just...
On the 26th of September 2022, a 570-kilogram spacecraft, the size of a refrigerator, rammed into an asteroid at 6 kilometers per second, launched aboard the fossil fuel-powered Falcon 9. The dinosaurs finally clapped back. 66 million years after the asteroid that ended the dinosaurs, an
All right. Okay, I just messed it up again. Why do I keep messing this up? How? Yeah, no, it's not. Let me get my glasses. It always helps when you can see what you're doing. Okay, let me. So if I put this in slideshow, current slide, okay, and I should be able to click on this, and it is not. God, not even that's doing it now. So how do I get out of this? Okay, I'm out of that. Nope. My God. Are we watching it now? Yay. This is actual video from the DART spacecraft headed towards the asteroid that they want to bump into. They did it. And they were able to move it. And they moved, we certainly don't need to see that. And they were able to move it more than they anticipated that they were able to move it. And so it worked.
That showed the white ring was the original orbit, and it bumped it into the blue.
Yes.
orbit.
Yeah. So it worked.
Did the asteroids stay together?
Yes, they did. And the objective was not to separate them. The objective was basically to see, hey, can we move the smaller one? Because they are gravitationally linked to one another. It worked, and it worked better than they thought it would. Okay, so it was a success. So NASA will grow it from here. Okay, I foresee that in the future they're going to attempt this again with a bigger one, and maybe different methods, maybe some type of a bomb or something to see what happens. But the good news is that there's hope. There's hope. If something goes wrong, maybe NASA can save us.
What was the risk factor of them bumping it into the wrong direction where it would have backfired?
Yeah, no, much of a risk factor because yeah.
They went out on the way here.
Yeah, it was out there, so they were good to go.
And what are those two names? What do they name it after?
Again, some of these, yeah, I don't know what the actual history is, but that's NASA again loving to name these things. All right, here's another exciting mission that occurred. How does NASA explore what's going on out there? The OSIRIS-REx spacecraft. What's going on the asteroids? What are they made of? Well, we don't exactly know unless we can go and get something from them. There are some meteorites that make it here to Earth, but it's different to be able to actually go and collect them in space rather than seeing what ends up here on Earth. So NASA sent this spacecraft, and let's see if I can get this to work. This is actual video, okay? All right, so let me start this again. This is a camera. This is real footage that was installed on the OSIRIS-REx spacecraft. Going in to collect a sample, bam, touch the asteroid, collected the sample, put it in a storage area, returned it to Earth. It landed in Utah, and it was successful. They actually collected more than they thought they were going to collect. Probably not. Probably not, because there's no atmosphere. There might have been life on the moon a long time ago, and that's one thing that NASA's looked into, but probably not now. Sorry?
I know there are like some moons, like worms on the moon, like
Worms.
Yeah, not that we know of, but I'm going to be talking about another moon in a moment, and it's very promising on this other moon. So let me stop this. Sorry for the technical problems here. All right. Again, takes a lot of smart people to be able to design, engineer, build a spacecraft, launch it from Earth, get it way out in the space, get it to land on a relatively small body that's moving very quickly, collect the sample, and get that sample back to Earth. That takes a lot to get all that done. But NASA does it. All right. Last major mission that I'd like to talk about is the Psyche mission. Is anyone familiar with the Psyche mission? All right, so okay. Here's a short video about the Psyche mission.
There aren't many classes of objects left in our solar system that we haven't looked at up. We haven't looked at up close with a spacecraft. And one of them that's left is the metal asteroids.
16 Psyche is an asteroid that orbits the sun out between Mars and Jupiter.
The reason that Psyche is unique is that it is metal rich. It's believed that it may be a remnant core of an early planetesimal that was formed in the very, very earliest parts of the formation of the solar system.
And after this planet started forming and this metal core formed inside of that, it collided with other bodies that then stripped off the rocky mantle, leaving this core in place.
This is the part of planets that we can't sample directly today.
It's too hot, the pressure's too high, our instruments would melt. Can't drill a hole that deep in the Earth or other planets. So how do we study the core of our planet?
Psyche gives us the opportunity to visit a core, the only way that humankind can ever do. And it would be the first metal object that humankind has ever visited.
After launch, we cruise through interplanetary space for a number of years. First, we fly by Mars for gravity assist that'll slingshot us into the asteroid belt. And then we're thrusting all the way from there to finally arriving at Psyche.
We'll go into 4 orbits to collect the necessary measurements that we need from our 3 primary instruments.
So our payload consists of a couple of imagers, which are cameras that take pictures of Psyche. Also a gamma ray neutron spectrometer, which allows us to measure the elemental composition of the surface of Psyche. And then a magnetometer, which will allow us to detect any magnetic field that's left at Psyche.
If Psyche still has some sort of remnant magnetic field, that probably tells us it really was a core. It's a strong indicator. We also use the radio on the spacecraft as an instrument, so we can map out the gravity and map out the interior structure that way.
We're using a particular thruster technology, Hall effect thruster technology. They operate 5 times more efficiently than normal rockets, so they use a lot less fuel, and is what allows us to get into orbit around this asteroid.
Solar electric propulsion has been around for quite a while, and it has flown before, but we're continuing to push the boundaries. We're going to have big 5-panel fold-out solar panels that will provide the electricity for the thrusters, which use as propellant the noble gas xenon.
This will be the first time that Hall effect thrusters have flown in deep space.
Studying the evolution of a planetary body is a detective story.
There's a magic too when you actually are on the launch pad and you say, we'll go for the launch.
And you feel like singing and dancing, and you feel like throwing up at the same time.
Let's go discover things about our solar system that we have no other way to do. I think that it's fundamental to who we are and also who we should be. It's an incredible opportunity to be a part of the team making that happen.
So in short, what are we doing? Well, we cannot study the inner core of our Earth, but what we can do is we can go to this type of an asteroid and we can do research there. We can't dig down that far down into the Earth, but this is believed to have been perhaps a planet that was forming. Before I forget, before you leave, I do have some freebies if you'd like to gather some, and I've got a sticker for the Psyche mission, and I've got some more information over here about the Psyche mission. Okay. One more video that I'd like to show you. I think I'm getting the hang of this now. I often like to encourage you, if you have never had the opportunity to see a launch from Kennedy Space Center, we do live right down the road, you absolutely need to take the opportunity to go over there and take a look at one. Has anyone had the opportunity to see a launch up close? So I did some work on the Psyche mission. And so I was fortunate enough to be invited to about as close as you can get to the launch pad to see this Falcon Heavy launch that launched Psyche. So here is the video that I was able to gather. I'm going to move it forward a little bit here. This is from the Saturn V Apollo Center, if you know where that is, at the visitor complex. So it's about 3-4 miles from the pad. Again, SpaceX Falcon Heavy rocket launching Psyche.
9, 8, 7, 6, 5, 4, 3, 2, 1.
And then it went right into the clouds. But it was really cool, a really cool opportunity, and I highly recommend that you take the opportunity, if you can, go out and watch a launch, to watch one. And at the Kennedy Space Center, I've got some brochures here. There are opportunities, if you pay a little extra, you can go to the same place that I went to see some other launch. So consider that. All right, so we are just about out of time. I want to mention 2 other things. Oh, I'm sorry. I forgot about Europa Clipper. So you were talking about, is there life on the moon? So far, we've not found life on our moon. However, scientists believe that if we find life in our solar system, the best chances will be a moon of Saturn or of Jupiter. So we had the Europa Clipper that launched just a few months ago from Kennedy Space Center. It's on its way to one of the moons of Jupiter. It's going to take quite some time to get there. When it gets there, it will not actually be in orbit around the moon. It will be in orbit around Jupiter. The reason for that is because if they put this spacecraft in orbit around the moon, it would get too much radiation from Jupiter. So they're going to be doing elongated approaches and when they go in to take a look at Europa from, again, orbiting Jupiter. So
that's the name of the moon?
That's the name of the moon, yep, Europa, and so they named it the Europa Clipper. Yes, yep. So it's not landing, all right? The future mission, perhaps, we will be landing on Europa, but right now this is just going to orbit it. I don't believe that there's an atmosphere. So this is ice, frozen ice that's about 6 miles deep.
That's pretty deep.
But this is, again, a moon of Jupiter. And so Jupiter is so big that it's tugging on these planets, which is creating heat, thermal heat. And so scientists believe that underneath this frozen ice, there's liquid water that's being heated by the tugging of Jupiter. And it seems to have the right ingredients for life. And so we're going to go explore to see, in fact, is that the case? And then again, hopefully in the future, send a lander, hopefully we can come up with the technology to drill that far down and then put something down in there, a little, you know, submarine or a camera, and see what might be going on down there. So if we discover life in our solar system, this is a very, very high candidate.
When we say life, we're talking about like
Yeah, 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 right, right. Okay. Yes. All right. NASA Eyes, I mentioned it earlier. Really, really cool. If you've never done NASA Eyes on the internet, you simply NASA Eyes. Okay. NASA Eyes. There are several different types. I like to go to Eyes on the solar system. You want to find out where anything is, any spacecraft that NASA has ever launched that's still up there and working, like the Voyagers that were launched in the 1970s, right up to James Webb and the Europa Clipper. You go here and you take a look. For example, talked about OSIRIS-REx, that spacecraft that collected the sample from, so they've renamed it. They're doing another mission. That's where that spacecraft is right now. Lucy is another mission, but here you can zoom in and zoom out. So if we zoom way out, there's Voyager 1, Voyager 2 down here. And so you can put in any of the missions that we spoke about, Psyche or Europa, and you can see exactly where they are. You click on it. You can take a look at what the satellite looks like, all kinds of cool things. So check out NASA Eyes. NASA Eyes. And the last thing I want to mention is citizen science, and especially for the young people here in the room. If you want to get involved, NASA provides lots of opportunities for people, adults and children, to get involved in citizen science. So if you go NASA citizen science in Google, you will see all kinds of opportunities that you can get involved with something as simple as your smartphone. Okay. All right, so we are out of time, but I'd like to ask if anyone has any questions.
Any updated information on Rome?
Nancy Rome. Yep, I got a little sticker here. Yes, they're busy at work. Okay, you got one. So they're busy at work, working on it, and I don't know what the launch date is.
2027 sometime.
Yeah, yeah. So.
So you have your own YouTube channel, we can look at stuff.
Yeah, so please, if you are interested, you can scan this with your phone and you can check out my YouTube channel, or I have a little slip over here. I was invited back to another NASA event.
Time to do this and what?
I don't. I was invited back to NASA this summer to watch another launch, and it was no clouds, and it was a Falcon Heavy, and it was absolutely incredible. And I've got some video on my YouTube channel, so really, really exciting. Check it out.
What year was the first rocket
Launched the first, well, it depends, because before the Apollo program that I spoke of earlier, there were two other programs, Mercury and
I was too young.
Gemini. And so that was like back in the 1950s.
I wasn't born yet.
So yeah, the 1950s.
So the first launch was in the 1950s?
Yep, yes, 1950s. Okay. Well, I want to thank you so much for coming. I hope that you learned something, that you enjoyed it. If you would like, NASA always likes me to submit pictures of those that came to the event. So if you're interested, NASA's very, very picky on pictures and things like that. I would have to have you fill out a waiver, a release form, and then maybe we can take a picture up here. If you want to email me, I would be glad to send you the picture. If you don't want it, no problem. But I would send this picture to NASA, and sometimes they use this in some type of promotion that they might do. So who knows, you might become famous one day. So if you'd like to do that, I've got a form for adults. I've got a form for children. So just fill these out. You don't need to give me your full address. If you don't want to be in it, No problem. Question?
So there was a question in the chat box about India and their space program.
Okay, so yes, hello. Yeah, it's good to know someone's watching the YouTube channel. So I don't have a lot of information about India's space program as I represent NASA, but it's very exciting to see that there are other countries around the world that are interested in space exploration and making this a priority for their country. So it's exciting to see other countries that are getting involved. To me, it's not a threat. I don't think it's a threat to NASA. We humans all need to come together, work together, and we can do big, awesome things. So I think it's awesome.
India needs to feed its people before it spends money on a space program.
All right, again, thanks for coming. Thank you. Pick up some freebies. If you want to be in the picture, just fill out those forms, and once everyone's done, we'll get to the picture. And I'm going to end, let me grab my glasses here. I'm going to end this.
So are you planning on doing some type of group picture?
Yeah, whoever would like to be in the picture, we're going to do it once everyone gets these forms filled out. Yep. All right. So I'm going to end this. Thank you all so much for coming.
Thank you very much.
Thank you.